Okay guys, let's look at this problem. It says find the area of the shape formed by f of x equals 2x plus 4 and the x-axis and the line x equals 1. So there's a shape that is formed by these three graphs, and we're going to draw the shape and highlight it first. How do you draw f of x equals 2x plus 4? What's f of x really? F of x is just a code word for y. So we want to graph y equals 2x plus 4. That means this is a line. The y-intercept is 4. 1, 2, 3, 4. And the slope is a positive 2. So 2 up, 1 over, 2 down, 1 over, 2 down, 1 over. So this must be negative 2 here, negative 1 here. And let's connect. Oops. Let's connect these dots and make a line. Okay, so this line here represents y equals 2x plus 4. We also need this line here, the x-axis. So here's the x-axis line. And really that equation is y equals 0. The equation for this line is y equals 2x plus 4. The equation for this line is y equals 0. What's the line look like, the x equals 1 line look like? Is it horizontal or is it vertical? Y x equals 1 is going to be a vertical line through x equals 1. So here's 1. So it's going to be a line that looks like this, a vertical line. Okay, and let's go ahead and shade the region that is bounded by these three graphs. It's very important to shade in this unit. It helps you to see your boundaries, and that's pretty important. Okay, so I've got my shaded area here, and I want to find the shape formed by this shaded area. And one thing I learned last year was that if I make a rectangular bar here, and I make an infinite number of them, a million of them, an infinite number of them, and I made them smaller and smaller and smaller until there's an infinite number, I can find the area under the curve, or I can find the area of this yellow figure here. So if I just take out one of these bars, let me just look at it. If I took out one of these bars and made it look like a bar, do you agree the width of any one of these bars is going to be delta x? And what's the height of this bar? The height of any line on a graph, let's think about this. If I had a graph and I wanted to know the height of this line from this point to this point, and let's say this point is 8 and this point is negative 2, then what is the length of this line or the height of this line? Wouldn't that be 8 minus negative 2? Right? So the height of this rectangular, wouldn't it be this y value minus this y value? So this y value here for any x, this y value here is going to be y equals 2x plus 4, right? I mean, grab any of these rectangles. Any rectangle that I draw that's vertical here, this y value is going to be 2x plus 4 for this x value. For this x value here, it'll be 2x plus 4. For this x value here, it'll be 2x plus 4. So let me label this. This is negative 2 here, I believe, and this here is negative 1, and this is 1. So if I wanted to know the length of this rectangle, the bottom y value is what? Y equals 0. So if I subtract 2x plus 4 minus 0, then that is the length right here, okay, of this rectangle, this blue rectangle. So this length is 2x plus 4 minus 0. Okay, so if I wanted the area of one of these rectangles, okay, if I remember a long time ago, what I did was I would sum up the areas of all the rectangles, okay, and this right here represented the area of a rectangle. Now, if I summed them up and I took the limit as delta x went to 0, or as n goes to infinity, what I would get is the limit definition of a definite integral. Okay, so what I'm going to do is I'm going to figure out what this is here, this area of the rectangle. Okay, I'm going to put it right here, And then I'm going to sum it over an infinite number of rectangles, and that will give me the area of this highlighted region. And so f of x times delta x in this situation, meaning this f of x really isn't just f of x, it's the height of the rectangle. And the height of the rectangle for this problem is 2x plus 4 minus 0. Okay, I'm going to take this and multiply it by dx, okay, because that's the area of one of these rectangles. I'm going to sum it up over all the x's that I have, okay? But what x do I start with? If this is an x, then that must mean that these limits are x. What x do I start summing up the Riemann sum? And at what x do I stop? -2 to 1. And if I integrate this, I should get the area bounded by these three lines. So let's go ahead and integrate this. Remember, the integral of f of x dx is equal to the antiderivative. This is the first fundamental theorem of calculus. Okay, the antiderivative, first you plug in your b, then you plug in your a, then you slap a minus sign in the middle. So this is going to be 2x squared over 2 plus 4x, and the 0 I can ignore. And this will be go from -2 to 1. I can actually ignore that part right there. And this answer is going to be, first I plug in the 1, then I plug in the -2, then I slap a minus sign in the middle. That's this minus sign right here. This is my f of b. This is my f of a, or f of -2, so to speak. This is my f of 1, and then I slap a minus sign in the middle. So this answer is 5 minus -4, which is 9. So the area bounded by these three graphs is 9 square units. And let's see if that makes sense. I can actually go up here and look at this triangle, and I can actually find the area of this triangle, not using calculus this time. I can actually find the area of the triangle using geometry, right? It's a right triangle here. So this is a right triangle. And what I'm going to do is get the formula for a right triangle, and that's the area is equal to 1/2 base times height. 1/2 of the base, what's the length of the base? 1, 2, 3. What's the length of the height? 1, 2, 3, 4, 5, 6. Is this equal to 9? Yeah, it is the exact same as when we used calculus to do that. And why did we do this? Because for the problems that you work, this y is not going to be y equals 0. It'll be something else, and whatever it is, okay, you'll subtract it right here. All right, you'll have lots of curvy curves, not such nice geometric figures like this right triangle. Okay, so you have something that looks like this. I think I typed into your problem on this side already, right? So let me, so your problem is going to be y equals 6 minus x squared and y equals x. Okay, so what we're going to do is we're going to find the area, and I wrote area for you, but it's really the area between two curves. So just FYI, that's really what we're doing. Area between two curves, okay, technically. And so what we're going to do is, the first thing we're going to do is we're going to find the intersecting points. We're going to find the intersecting points. You'll see why in a second. I'd like to ask you to stay to the left side, please, of your foldable. I'm going to go to the right side, okay? But you guys stay to the left side because you're going to need a dy problem in a second. Okay, so first we're going to have to graph y equals 6 minus x squared. What does y equals 6 minus x squared look like? Again, guys, stay to the left of your phone.
Upside down.
Upside down parabola. Okay. How did you know that it was upside down? Okay, because if you have a y equals x squared, okay, that's going to be up or down parabola. If you have an x equals y squared, remember, why are you scared? Look what? Left and right. Why scared? Why scared? You know, like, that's how my dad would say it. Why scared? Okay? So you'd look left and right. And if they're different signs, it would be the left. If they're the same signs, it'd be the right. Here, if they're different signs, it'd be the upside down. It'd be the frown. And if they're the same signs, you'd have a happy face, okay? So we're upside down, and what is the y-intercept? If x is 0, what's y? 6, okay? So I'm going to go here where where y is 6, and I'm going to do an upside down parabola. That's where I am. Okay, I also need y equals x. How do you draw y equals x? Okay, you guys okay with that? Y equals x. And let me label this function. This function here is y equals 6 minus x squared. So go ahead and highlight it, guys. If you have some sort of matte pencil, that would be nice. If you don't, you could just shade it in with your pencil. Okay. And I want you guys to see the borders of this. Okay. When you draw this the correct way, and again, you just sketch it, but if you sketched it mostly correctly, you can see that if I wanted this area, if I did a Riemann sum bar here, so let's look at some Riemann sum bars. Okay. I'm going to draw 3, but there's really an infinite number of Riemann sum bars here. Okay. If I took one of these Riemann sum bars out, okay, the height, the width of this would be dx. You see that? Or delta x. Okay. The height of this Riemann sum bar, see if this makes any sense to you. The height of this, if I wanted the length of any one of these Riemann sum bars, do you see it would be this y value minus this y value, right? And this y value up here is 6 minus x squared. And this y value down here is x. Okay, so I'm going to set this up into a definite integral to find the area that's highlighted here. Okay, but the problem is, how do I know when to start taking the integral and when to stop adding Riemann sum bars? I need the intersecting points. You guys see that? And so that's why I'm going to first find the intersecting points. How do I find these points? Okay, set them equal to each other, right? So let me erase this. To find the intersecting points, I'm going to go ahead and set them equal. So it'll be 6 minus x squared is equal to x. So I'm going to move everything to the right. So that's going to give me x squared plus x minus 6 is equal to 0. Okay. Solve for x. So I'll get x plus 3, x minus 2 is equal to 0. Again, guys, if you guys are having problems factoring, you go to Khan Academy, spend 30 minutes in Khan Academy, you'll master it, okay? You'll never have problems again, okay? That's worth your time, believe me. If you're going to go on with math, it's worth your time, okay? And then I'll get x is equal to negative 3 and x is equal to 2. So what that means is this point right here, which one makes more sense? Would it be the negative 3 or the 2? It'd be the negative 3. Over here, this point right here, these are the intersecting points. This would be 2 comma something. How do I get the y value? Yeah, plug it into, well, question, plug it into the first equation or the second equation? It doesn't matter. You should get the same answer. Okay, so if I plug it into this y equals x, because that's easier, this will be negative 3. This will be also 2. Okay, so I've found the intersecting points, and the second thing you do is you find the area. Okay, and again, to find the area, you guys have that rectangle. Okay, you just find the area of one rectangle and then just integrate it, okay, all the way across. So remember, this is a dx width. Okay, if I took one of these Riemann sums and blew it up, this length again, the length of this thing is going to be this y minus this y. The top y was 6 minus x squared. The bottom y is x. So the way the problem is going to be, okay, this f of x times delta x, remember this is a sum, okay, this part right here represents the area of a Riemann sum bar, of one bar, okay. The area of one bar is going to be 6 minus x squared minus x. You guys see what I'm getting? 6 minus x squared minus x, right? Because the height, the length of this is this height, or this y minus this y. So the length of this is 6 minus x squared minus x, okay? The width of this is dx, so I'm just going to say this is dx, and I want to take the limit of this thing as delta x goes to 0, so this would be the integral. So this becomes the integral, because the definition of a definite integral. This is the integral of, and be careful with this, since this is a dx problem, okay, what kind of values are going to be here? X value. If it is a dy problem, which is the most common mistake students make, if it is a dy problem, I would not pull the x values. I would pull, what do you think? the y values. But this is a dx problem, so I'm going to go find the x values. So I go look at my picture, I've shaded it in, and I go, okay, what x is the most left x, the furthest left x that I'm going to start at? So what is this x value right here? -3. And it just so happens that this x and this y are the same, but I'm really pulling this number. You guys see that? What is the furthest right number that I would pull, the biggest x that I would pull? 2. So this will go from -3 to 2. And there is my integral. Okay? On numbers 1 through 5 on your homework, all you have to do is set this up. Okay? And then the subsequent problems, you actually need to integrate it. So let's go ahead and integrate this. Right? This integral would be 6x minus x cubed over 3 minus x squared from, oh no, x squared over 2, from -3 to 2. Okay, it's been a long time since we've done integrals, so let's do this together. 6x minus x cubed over 3 minus x squared over 2 from -3 to 2. The first fundamental theorem of calculus says, first I'm going to plug in the 2, then I'm going to plug in the -3, then I'm going to slap a minus sign in between. So when I plug in the 2, I get 12 minus 8 over 3 minus 4 over 2, which is 2. When I plug in the -3, I get -18 minus -27 over 3 minus -3 times -3, which is +9 over 2. Okay? First I plug in the 2, then I plug in the -3, then I slap a minus sign between. But be careful. You guys good that the minus sign affects that whole expression on the right. Okay? Because this is your f of b minus your f of a. First fundamental theorem of calculus. Okay? And then I'm going to simplify this. This is going to be 10 minus 8 over 3 on this side. On the right side, this is really negative, just positive. You guys okay with that? So this is really just 9. So what I have is -9 minus 9 over 2. This is 10 minus 8 over 3 minus this right here. Let me just change it all to positive. Are you guys okay if I change it to positive? So this would be positive, positive. So this would be plus. And if I get a common denominator, well, let me not do a common denominator yet. This would be just 9 plus 9 over 2. And the common denominator is 6. And I know this is really tedious, but AP expects you to be able to, add simple fractions. Okay, so this is probably like, I don't know, 5th grade math. I don't know when you guys did fractions. 5th grade math, or you guys are GT, maybe 1st grade. Okay, but I'm going to get a common denominator of 6. Okay, so this will be 60 over 6 minus 16, right? Multiply by 2, 16 over 6 plus. If I get a common denominator of 6 here, that would be 54 over 6. Common denominator of 6 here, that would be 27. Multiply by 3, right? Over 6. Okay. Then I'm just going to add and subtract the first row here. Quick, someone who did Q1, tell me what this is. Sad, grandson here. What is that, guys? Is it like 100 something? We are in so much trouble. Okay. 71, 60 minus 16 is 84, right? So it's 80, no, that's not 84. 44? So no, that's not right. I'm getting 115, but I don't think that's right. 54 plus 27 is 1, oh, this is 8. So then 125, there it is, over 6. Okay, and there's your answer. Okay, any questions on this problem? All right, so on your test, you'll have a calculator, so you could actually do this with a calculator. But I'm going to ask you, if you can, if it looks simple, try to do it with fractions, because AP expects you to know simple fractions like this. Okay, they've done lots of fractions like this as a free response question. On your homework, 1 through 5 is just setting up the problem. I'm not done yet, but I'm just letting you know. Number 6A, you want to use a calculator. So just letting you know, number 6A, you want to use a calculator. The rest I did without using a calculator. And you guys can just kind of use your discretion. If it takes you a long time, go for the calculator. If you feel like you're comfortable with it, you don't have to use a calculator. Okay? So this is the area that was highlighted by this curve. Okay? Any questions on the dx side? Okay, Okay, you guys ready for the dy side? All right. So let me just, before we go deep into the dy side, let me show you a picture. I want to see if this makes any sense to you. If I gave you a graph like this, where the function, like this is f of x, it crisscrosses with the g of x, okay? If you did a Riemann sum bar, okay, if I did a Riemann sum bar over here, the area of this Riemann sum bar on the left side, okay, it would be a width of dx, of course, because that's a dx width, but this length here would be, it would be f minus g, right? Because if I asked you for the length of a line, a vertical line, you'd just say, okay, it's just this y value minus this y value. You agree with that? But when you switch over to where they crisscross, do you understand? This Riemann sum bar has a different area, right? Okay, so I'm going to draw a Riemann sum bar here. And how is this one different? It still has a dx width, but what is this height going to be now? G minus f. So when you have different Riemann sum bars, what you're going to have to do is split it into two different integral problems. Okay, and so you'll just add them separately. So see if this makes sense. This from 0 to x1, that area, this yellow highlighted area, would be the f minus g times dx, right? So here you have the f minus g times dx, okay, from the smallest x to the biggest x. Why am I using x's here? Because this is a dx problem, okay? If I wanted also to add this area, I'd have to add another term here. This area is g minus f times dx. So this would be g minus f dx. I don't know why the dx is subscripted there. It should be up here. Okay, and this would be from x1 to x2. You guys see that? So you have to split it when your Riemann sum doesn't stay exactly the same. Okay, now there's a, sometimes instead of splitting it, sometimes you have to split it, you don't have a choice. But sometimes instead of splitting it, you can change the direction of your Riemann sum. Instead of making a vertical bar, you can make it a horizontal bar, okay? And sometimes it's easier to do it that way. So let's look at this problem here on the right side of your area, foldable, okay? And again, the first thing we're going to do is we're going to find the intersecting points, okay? In order to do that, a lot of times I graph it. So I'm going to go ahead and graph it to see what this thing looks like, okay? How do I graph x equals 3 minus y squared? It's a left, what? It's a left parabola, right? It's a left parabola with, if y were 0, what would x be? 3. So if y is 0, x is 3. So this would be 3, 0. Okay, so it goes through that point. It's a left parabola. If y is 1, actually, let me make y 2, 1. If y were 1, what would x be? 2. Okay, you agree with that or not? If y is 1, x would be 2. Okay, what if y were, did I do that right? No, this should be switched, right? If y is 1, x would be 2. So this is actually not right. This should be right here. Sorry about that. You guys good with that? If y is 1, x would be 2, right? What if y is negative 1? X would still be 2, right? So I'm going to come down here and say, okay, well, if I had a negative 1 here, x would be 2. So right here, 2, negative 1. So I can kind of draw this parabola. I knew it was a left parabola. And it goes through 2, 1, and 2, negative 1. Something like that, okay? You will have your calculator for the test. Okay, you have to draw all of these graphs. But I want to let you know that this graph is not drawable by your calculator. You guys good with that? Why is it not drawable by your calculator? It's not, yeah, it's not a function. Okay, if you graph this in your calculator will only do this part right here. That's the only part it will do. Just let you know, because it's not a function. Okay, so if you graph this in your calculator, you would have to say that you understand that x equals 3 minus y squared is actually equal to y squared equals to 3 minus x. And the thing that students do wrong, I'm just letting you know, is they don't understand that this is a left-facing parabola. So they'll say that this is equal to y equals square root of 3 minus x. They'll graph this in the calculator. And this only draws this part. Does that make sense? And you'll have your highlighted portion wrong, just let you know. if you really did this right, this is not equal to square root of 3 minus x. What is this equal to? Plus or minus, okay, square root of 3 minus x. And if you put this in your calculator as y1 and put this in your calculator as y2, then you will have the full, does that make sense, the full parabola, because you need two functions combined, basically. Okay, and I say this, but I would say this is probably the number one missed thing on the test. So just be careful with this. Know how to draw left and right parabolas. Okay. All right, then I'm going to graph this x equals y plus 1. This is really hard to graph the way it is here. So I'm going to change this to y equals x minus 1. This is a lot easier to graph. This tells me that my intercept is where? -1. If I make, let me see, if I make y 0, then x is actually 1. So actually there's a point here too. I think it actually goes to this point. If I make x equals 2, then y actually is 1. So it actually goes through this point here, this 2, 1 point. So let me go ahead and draw this line. Okay. All right, go ahead and highlight the portion that we're trying to find the area of. Okay with that? And if I did a vertical Riemann sum bar here, okay, you guys don't draw this in, but let me draw it in. I want you guys to work with me on this, okay? Because what you're going to have to do on your test and even on your AP exam is figure out, is it better to do a vertical Riemann sum bar or a horizontal Riemann sum bar, okay? In some situations, both are bad, okay? But in some situations, like this one, do you see that this gives you a different y minus y than this would give you? You guys see that? So maybe if I drew a horizontal Riemann sum bar, it would be better here. Do you guys see why I don't want to do the vertical? I mean, sometimes you just have to do the vertical. It would just be two integrals, okay? But instead of doing a vertical Riemann sum bar, what if I did a horizontal Riemann sum bar? Let me just think about this. A whole bunch of horizontal Riemann sum bars, okay? Let me just pull one of these bars out. I'm going to pull one bar out. What would be the width of this, I guess, or the height of this thing, the short width of this? You see it be a dy? Now instead of a dx, it's a dy because it's a dy width. Okay. What would the length of this be? And I'm trying to just find the area of a rectangle. What would be the length? So let me just talk to you guys. If I had a horizontal line, what would be the length of this line? And let's say I said this was 9 and this was -2. What would be the length of this line? Wouldn't it be 9 minus -2, right? So instead of y minus y, it's really just what? X minus x, right? So if it's horizontal, just make sure you understand, if it's a horizontal line, you would never do y minus y. That would be silly, right? You would do x minus x. So let's grab this x value and subtract this x value, okay? So what's the x value right here? For every one of these bars that I draw horizontally, what's the x value always here? Agree? It's always 3 minus y squared. Now what would this x value be always on this left side of all of these bars? X equals y plus 1, okay? And what do you know? They gave you this in terms of x's, okay? You got to be careful. Sometimes they give you in terms of y. If you decide to make horizontal bars, you need to change it to x's. Okay, that's the tricky thing about these problems. The more you do, the better you'll get at it. Okay? All right, so when I set this up into an integral, I still don't know the limits, and that's why I'm going to find the intersecting points. So let me find this point and this point, so I can figure out when do I start integrating and when do I stop integrating. Okay? Now, let's see, let's get these points here. How do I get these 2 points? Okay, just set the functions equal, right? Or plug in x for your y, plug in y for your x, or something like that. If I move everything to the right side, I'll get y squared plus y minus 2 is equal to 0. Okay, solve for your y. So this will be y plus 2, y minus 1 is equal to 0. I'll get y equals -2 and y equals 1. Now this is my y value. When y is -2, what's my x value and how do I find it? When y is -2, what's my x value? Is it 1? -1. You guys good with that? If I plug in -2, I'll get -1. Okay, if y is 1, what's my x value? It's getting 2. Which equation did you plug it in to get that? The second? What if you plug in the first? You get the same, okay? So these are my 2 points. Okay, let me go put it on my graph. So this point here, 2, 1 is already there. This point here must be -1, -2. Okay, now give me the intersecting points, okay? Now, how do I set up the area? So the first thing you're going to do is find the intersecting points, okay, which we've done. The second thing you're going to do is find the area. Okay? Let's find the area. Remember, guys, the area is the integral of f of x dx, basically, okay? But this f of x dx is really just the area of one rectangle, okay? And you want to make sure the formula is always the same for every rectangle that you draw. And you can do it. Like, draw another rectangle, and see if this rectangle actually fits the same formula. Does that make sense? Make sure that all the rectangles you draw fit the same formula. If it doesn't, then you kind of need a 2 integral. Does that make sense instead of 1? Okay. So if I look at this, this area of the rectangle is going to be. Let me see if I can work a little bit more on the top here. I'll do the area of the rectangle. So this, maybe not. Maybe not. The area of the rectangle is going to be, here, let me erase, let me erase this left side. Okay, the area of the rectangle is going to be the integral of x minus x, so this length right here, which would be 3 minus y squared minus quantity y plus 1 dy. You guys with me on that? Because this is just the area of a rectangle. The area of the rectangle is this length down here, this length right here. And what is this length? This length is x minus x. The right minus the left. Okay? Times dy, that's the width. And I want to sum it up, an infinite number of Riemann sum bars, okay, from y1 to y2. Is everybody good with the y1 to y2? Okay, so I'm going to put the lowest y1 here. What's the smallest y1 in the shaded area? Where do I start integrating? -2. Do you guys see that we're pulling this number right here? Do not pull your x value if this says y. Is everybody good with that? Number 2 mistake students make, okay? This says y, make sure you're pulling a y value. What is the highest y value I'm going to integrate to? 1. Okay, so this will go from -2 to 1. Okay, and we've done several problems by hand. Let's go ahead and do this one with a calculator. Okay, so I'm going to pull up a calculator here. You guys can pull out your calculator, see if we remember how to do integration with your calculator. Let's do a Math 9. Okay, the lower limit is going to be a -2. The upper limit is going to be a 1. Okay. Now, even though this says y's, and you can put y's in your calculator, but if you put a y, it's more than just one button, right? You have to hit like alpha y. Okay. So instead of doing alpha y, I'm just going to call all of my y's x. Will I get the same answer? Yeah, your calculator doesn't know the difference. Okay. It's just some variable. So I'm going to put in 3 minus x squared. Okay. And then be careful with this. This is going to be, this negative is going to be distributed. So it's going to be -x minus 1. Okay, and then I'll put an x there. Okay, that's good. All right, hit enter. And this should be the area of the highlighted region. And that answer is going to be 4.5. So we did this with a calculator. And for fun, if you wanted to on your own, you could do it without a calculator. Okay? Any questions on how to do these problems? All right. So guys, go ahead and get started on your homework. You have 6 minutes? No, you have 3 minutes. And let me show you, I mean, if you just look at number 1, let me just show you what we're asking for. Number 1 through 5, we're just setting up the problem. Okay, so let's go to number 1 here. Okay, and then just a note, while for this homework, a lot of the figures are drawn for you, your test will have none drawn for you. Okay, so make sure that you know how to draw these figures. So if you look at number 1 here, you want the area under this, the highlighted area here, and you got to decide, do I want a vertical Riemann-Sum bar, or do I want a horizontal Riemann-Sum bar? You guys see, like that's the question. You'll do something, you'll set it up differently, whether you do vertical or horizontal. What I do is I always start with a vertical, because the verticals will have x's in it, okay? And that makes the problem a lot easier, okay? It's really weird. The one that starts with a y equals will have x's in it. The one that starts with an x equals will have y's in it, okay? Which is kind of weird. But I'm going to start with a vertical. And I'm going to say, okay, if I draw every vertical bar, okay, would I have the same formula for every bar? Would this y be the same as this y? Would this y be the same as this y? Does that make sense? So let's go ahead and figure this out. This right here is your y equals 0. Right? This is this problem right here. Remember, g of x is really just a code word for y. Your y equals x squared minus 6x is this part right here. So this is y equals x squared minus 6x. Okay? If I got one of these red rectangles and pulled it out, the width would be dx. The height of one of these would be 0 minus x squared plus 6x. Are you guys okay with that? Do you see where I got that? It's the top y minus the bottom y. Is good with that? So what would be the area of this curve? This curve would be the area of this rectangle, which would be negative x squared plus 6x, the integral, times dx, right? One of those rectangles, that's what it would be, okay? But then you want to sum it up from, and this is an x, so then you look at this and you say, what's the smallest x value and what's the biggest x values? And don't get your x's confused with your y's. Okay, so what's your smallest x value here? 0. What's your biggest x value here? What is, I can't even tell. What is this biggest x value here? Is it 6? You might want to calculate to make sure. It looks like 6, okay? And there is your first setup. Are you guys good on how this goes? Sometimes you have to solve it. 1 through 5, you won't have to solve it. You just have to set it up. But subsequent ones, you're going to want to solve it.